Hello everyone, welcome to the fourth lecture of the video lecture series on basic computer programming hosted by Coding Chip. Myself Chetan Kamani, lecturer in Government Polytechnic, Jamnagar. So in the previous lecture I have already discussed various examples of an algorithm using selection control structure, and in today's lecture I will discuss some examples of algorithm using looping control structure. So by attending this session, you will be able to design basic algorithm using looping control structure, or either we can say repetition control structure. So in this video lecture, I will solve 5 different problems of an algorithm using looping control structure. Very first problem is to calculate the sum of first n decimal number. Second is to calculate the sum of first and odd numbers. Third is to check whether the given number is prime or not. So to understand the logic for this problem, that is third one, you must have idea about the prime number. Fourth is to find the factorial of the given number. Same as the third one, you must have idea about the factorial number. And the fifth one is to print the Fibonacci series up to n term. So again, in this case also you must have idea about the Fibonacci series. So if you do not have idea about this three things, then you can check on the internet. Don't worry, I will explain little bit about the concepts in this video lecture about these three concepts. Okay, so let's start discussion. Let's start solving of the first problem using looping, or either we can say repetition control structure. So what is the first problem here? Write an algorithm to calculate the sum of first and decimal number. So in this case you have to consider decimal number starting from the first, that is 1, because I will not consider 0 in this case, because 0 plus anything, that number is all the same number, right? 0 plus 1 is equal to 1, 0 plus 2 is equal to 2. So in this case the first number is 1. So let's uh, design the algorithm. Let's Okay, so if you want to do such kind of things in mathematics, let's say n is the last term, there is a specific series, there is a specific formula to calculate the addition of first n numbers. Sigma n is equal to n plus 1 divided by 2. In this case 10 is the last term, 10 into 11 divided by 2, 110 divided by 2, which is equal to 55. Okay, in mathematics it is very easy to find the addition, but in computer we have to design this logic so that we can easily get the same value, right? So what should be the input for this algorithm? Input would be the last term, output addition from 1 to n, right? So how do we solve this problem? We have to take some variables, and by using that variables we will design logic. Okay, so how many variables we have to take? But obvious, n to store the final term, the second sum to store the addition, and the starting point, third is to indicate the starting point. Okay, so what is the logic here? First of all, we will calculate the addition. Sum is equal to sum plus I will initialize some variable by 0, and then we have to increment I by 1. Then we have to check the value of I less than or equal to n or not. If this condition becomes true, then we have to perform the same step like this. If this condition becomes false, then we have to, our result is in variable sum, right? So let me explain the logic. As I explained, the value of the input for this algorithm is value n. The output for this algorithm is addition of number 1 to n. And very first step of any algorithm is start. The second step, we have to take value from the user, that is n. The third step, we have to initialize two variable I by 1 and sum is equal to 0. Then we have to calculate sum as I explained. Sum is equal to sum plus I. Then we have to increment the value of I by 1. Then we have to check whether the value of I is less than or n or not. If it is true, then we have to execute, we have to transfer control to the step number 4 and execute step 4, 5, 6. Again we have to check whether the value of I is less than or equal to n or not. If it is not, then the result of the addition, it is in variable sum, and the final step is stop. Okay, so let's trace this algorithm. Very first step is start. Tracing is very important. If you are good at tracing, then you will able to find the uh, error in the logic. N, suppose in this case the value of n is 5. I am taking small numbers because in tracing, if I take big number, then tracing will take time. Okay, to understand the logic does not do not need to have large numbers, right? Then step number 3, I will initialize I by 1 and sum by 0. Okay, this step. Now step number 4. What is step number 4 here? Sum is equal to sum plus I. What is the value of sum here? 0. What is the value of I here? 1. Sum is equal to 1. Now the value of variable sum is 1. Then what is step number 5? I is equal to I plus 1. What is the value of I? 1. 1 plus 1, which is equal to 2. Right? The I value of I will be updated by 2. Then we have to check step number 6. Value of I is less than or equal to n or not. Yes, 2 is less than or equal to 5, which is true. Then again we have to perform the same step. What is the value of sum right now? 1. What is the value of I? It is 2. 1 plus 2, 3. The value of sum is updated by 3. Then I, what is the value of I? 2. 2 plus 1, 3. Then value of I is also 3 right now. Then 3 is less than or equal to 5. Yes, it is true. Then again we have to perform the same step. What is the value of sum? 3. What is the value of I? 3. 3 plus 3, 6. The value of sum is 6 now. Again we have to increment. We have to update the value of I. 3 plus 1. What is the value of I? Is 4 right now. 4 is less than or equal to 5. It is also true. Then again we have to execute the step number 4. What is the value of sum right now? 6. What is the value of I? 4. 6 plus 4, 10. The value of sum is now 10. What is the value of I right now? 4. 4 plus 1, which is equal to 5. Okay, 5 is less than or equal to 5. Yes, it is less than or equal to 5. Then again we have to execute step number 4. What is the value of sum? 10. What is the value of I forget to update 5. 10 plus 5, 15. Okay, what is the value of I? 5. 5 plus 1, 6. The value of sum is 15. Value of I is 6. 6 is less than or equal to 5. No, it is false. Then step 7 will execute print sum. What is the value of sum? It is 15. Okay, so by this algorithm we get value 15. But let me check whether this value is true or not. As I explained, there is a mathematical formula to calculate the addition of first n number. N into n plus 1 divided by 2. What is the value of n? 5. 5 into 6 divided by 2. 30 divided by 2, which is equal to 15. Yes, this value is true. That means the solution of this algorithm is true. I hope you have clear idea about this logic. If you have any doubt regarding this problem, then you can write in the comment box. Okay, so let's now start discussion on the second problem. So what is this problem is, write an algorithm to calculate the sum of first n odd numbers. Okay, what was the previous problem? we have to add sum of first and decimal numbers, but in this case we have to add sum of first and odd numbers. So what should be the input? The input is the how many odd numbers you want to add, that is n. And what would be the output? The output would be how the addition of first and odd numbers from 1, starting from 1. So in this case, how do we solve this problem? Let me explain the logic here. So we have to take value n from the user, then we have to take variable m. I will initialize this variable by 0. Then we have to take starting point variable I. Then we have to take another variable count, and I will initialize this variable by 0. Why count? Because we have to match how many odd numbers we have processed so far. Whatever number I will process, whatever odd number I will process, I will increment count by 1, and I will check the value of count with n. If it is less than n, then we have to process another number. So let me explain the logic. We have to calculate sum is equal to sum plus I, as we have done in the previous one. In this case, I have to increment I by 2. Why I by 2? Because if this is the odd number, if I will add 2 in that number, then the next odd number we will get. Okay, then we have to increment count by 1. Then we have to check if count is less than n, then go to this step. We have to perform this step unless and until the count is less than condition becomes false. Okay, so let's start. As I explained, the value of n, that is the number, how many odd numbers you want to process. Then output the addition of first and odd numbers starting from 1. Step 1 start. Step 2 we have to take value from the user, that is the odd number. Step 3 we have to take three variables I, sum and count. I will be initialized by 1, sum will be initialized by 0, count will be initialized by 0. Step 4 we have to calculate addition, sum is equal to sum plus I. Then we have to calculate addition, we have to add I 2 value to the variable I is equal to I plus 2. Then the third one, calculate count is equal to count plus 1. We have to increment the value of the value of count by 1 as we process the as we have processed the odd number. Then step number 7, if the count value of count is less than n, then we have to again execute step 4, 5, 6. Okay, and if this condition becomes false, then we have to execute step number 8, that is the result, and step number 9 would be stop. Okay, let me trace this. Suppose I want to add first three odd number. What is the first three odd number? 1 plus 3 plus 5. What is the addition? 9. Okay, let me check whether this result I am getting by this algorithm or not. Start n. As you know that how many odd numbers? N, 3. Then variable I. What is the value of I? 1. What is the value of sum? 0. What is the value of count? 0. This step is over. Step 4. Sum is equal to sum plus I. What is the value of sum right now? Sum, it is 0. I, it is 1. 0 plus 1, 1. Now the value of sum variable is 1. Then I is equal to I plus 2. What is the value of I right now? It is 1. 1 plus 2, 3. The value of I is 3 now. Then we have to increment count. Count plus 1. What is the value of count? 0 plus 1, 1. That means we have processed one odd number so far. Then we have to check whether the count is less than or n or not. What is the value of count? 1. 1 is less than 3. Yes, it is true. Then again we have to execute step number 4. What is the step number 4? Sum is equal to sum plus I. What is the value of sum? 1. What is the value of I? 3. 1 plus 3, 4. Now the value of sum variable is 4. Then I by 2. What is the value of I? It is 3. 3 plus 2, 5. Now the value of I is 5. Then count. What is the value of count? 1. 1 plus 1, which is 2. Now check the condition. 2 is less than 3. Yes, it is also true. Then again step number 4. What is the value of sum right now? It is 4. What is the value of I? It is 5. 5 plus 4, 9. What is the value of I right now? 5. 5 plus 2, 7. The value of sum is 9. Value of I is 7. Then again 2 plus 1. As you know that count value is 2. 2 plus 1, which is equal to 3. 3 is less than 3. This is false. Then step 8 will execute. What is the value of sum right now? 9. We are getting the same. That means this algorithm is true. Okay, if you have any doubt regarding this algorithm, or if you have any other solutions regarding this algorithm, then you can write in the chat box. I hope the solution is you are able to understand, right? Step number 9 is stop. Now our next problem is write an algorithm to check whether the given number is prime or not. So before designing a solution for this given problem, you must have idea about the prime number. So my question is, what is prime number? A number which is only divisible by the number itself or 1. Let me tell you again. A number which is only divisible by number itself or 1. Completely divisible, right? So that number is known as prime number. Okay, let me show you on the Google. You can see the definition. A number that is divisible only by itself and 1. Divisible means if you get remainder 0, right? So what are the different prime numbers? You can see I'm giving you some examples of some prime number. 2 is the prime number, 3 is the prime number, 5 is the prime number, 7 is the prime number, and 11 is the prime number, right? So by looking at the screen, you will be able to know that the smallest prime number is 2. So let me give you some method. Let me explain some method. By using this method, you will be able to decide whether the given number is prime or not. Let's say 19 number. We have to check by using mathematics methods, by using different methods. We have to check whether the 19 is prime number or not. So very first step you have to perform is you have to find the square root of 19. So what is the square root of 19? It is 4 point something, right? You have to omit this part. You have to consider integer part only, that is 4. Then second step, you have to start dividing 19 from 2. Okay, you have to divide 19 by 2. 2 9 2 9 is 18. We are getting remainder 1. We are not getting remainder 0. So we have to divide 19 by 3. 3 6 is 18. We are also getting remainder 1. We are not getting remainder 0. Then we have to divide 19 by 4. 4 4 is 16. We are getting remainder 3. We are not getting remainder 0. But then we do not need to divide 19 by 5, because whenever you want to know whether the given number is prime or not, you must have to divide that number from 2 to the square root of that number. You can see the square root, right? If the given number is not completely divided by this 3 2 3 sorry 2 3 and 4, then this number is prime number. Okay, we do not need to divide 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 18. We do not need to do that. We have to find the square root of the number, then we have to start dividing by 2, 3 and the square root of that number. Okay, I hope you have idea about this. Let me give you another number. Let me 37. So what is very first step? Yes, you have to find the square root. Square root of which number? 37, which is 6 point something. You have to consider this integer part only. You have to omit this. Then second step, you have to start dividing 37 from which number? 2. 10 2s are 36. We are getting remainder 1. Then divide 37 by 3. 7. 3 2s are 6. We are getting remainder 1. We are not getting remainder 0. Then divide by 4. 4 9s are 36. Remainder 1. Then divide 37 by 5. 5 7 are 35. Remainder 2. Then divide 37 by 6. 6 6 are 36. Remainder 1. That means no number 2 to 6, that is square root of that number, completely divides 37. Completely means where you getting remainder 0, right? So there is no number between 2 to 6 completely divides 37. So 37 is the prime number. I hope you are getting this. If you have any doubts or if you have any some suggestions regarding this, you can ask in the comment box. Now we have to design an algorithm for this. So what should we have to do? We have to take input number from the user. The output is whether the given number is prime or not. Then what is next? We have to check whether whatever the number user have entered is 2 to number 2. If it is equal to 2, suppose n is the variable in which we will store user's value. If n is equal to 2, then n is definitely a prime number. If it n is prime, right? If n is not equal to 2, this operator is used as a not equal to. If it is not n is not equal to 2, then we have to find what? Square root of n. Then we have to start dividing n from 2 to square root of n. If any number between 2 to the square root of n divides n completely divides n, then that number is completely divides, then prime. Sorry, it is not prime, otherwise it is a prime number. First of all, we have to check whether n is equal to 2 or not. If it is equal to 2, then n is the definitely prime number. If it is not equal to 2, then we have to find the square root of the number and we have to start dividing number by 2, 3, 4 up to square root of n. If any of the number between 2 to square root of n completely divides the given number, then that number is not prime, otherwise it is a prime number, right? Okay, so let's start writing a solution for this problem. So what should be the input here? You can see the number n is the input which user will enter, and algorithm will give output whether the given number or entered number by the user is prime or not. As you know that the first step of any algorithm is start. Then the second step that we have to check whether we have to take input from the user, that is n number. Step 3, we have to set one variable for dividing the given number, that is I variable, and I will initialize this variable by 2. Then as I told you, we have to check whether the given number is 2 or not. If it is equal to 2, then that number is definitely a prime number. Okay, then if it is not divisible by, if it is not divisible by 2, sorry, if it is not equal to 2, then we have to find the square root of that number. Okay, then we have to start dividing the given number from 2 to the square root of number. If any number between the if any number in the range from 2 to the square root of that number completely divides the given number, and if you get remainder 0, then that number is not a prime number. Okay, so let me explain these steps by you taking one example. Let's say start read number n. In our case, the value of n is 11. Then next, the value of I equal to 2. Okay, then next, n is equal to 2. No, n is 11, I is 2, so this step becomes false. Then next step 5 will execute. Square root of n. So what is the square root of n? Square root of n, which is square root of 11, which is equal to 3. As you know that, look at the step. Square root of n is less than I. What is the square root of n? 3. 3 less than 2, which is true or false? It is false. So step 6 will execute. N modulo I equal to 0. What is the value of n? What is the value of n? 11. Modulo I, what is the value of I? 2. 11 modulo 2 is equal to 0? No, it is not equal to 0. So step 7 will execute. What is the step 7? We have to increment the value of I by 1. So the value of I will be 3 after executing this step. And the next step, go to step number 5. Again we have to find the square root of n. What is the square root of n? It is 3. What is the value of I? It is also 3. 3 is less than 3, which is false. Then we have to divide 11 by 3, and we have to check whether this division will give remainder 0 or not. But this division will not give remainder 0. So again we have to increment the value of I by 4. Okay, again we have to go to the step number 5. What is the step number 5? Square root of n. What is the square root of n? Which is 3. What is the value of I? Which is 4. 3 less than 4, which is true. Then which step will execute? Step 9. What is the step 9? N is the prime number. You can see 11 is the prime number. Then stop. I hope you get this algorithm. If you have any query regarding this algorithm, then you can write in the comment box. Our next problem is we have to find whether the given number, sorry, we have to find the factorial of the given number. Okay, you must have idea about the factorial, right? Let me show you what is factorial. 5 factorial. This symbol is used to denote factorial. What is 5 factorial? How do we calculate? 5 into 4 into 3 into 2 into 1. Okay, then multiply this 120. 5 factorial 120. Then find 6 factorial. 6 into 5 into 4 into 3 into 2 into 1, which is equal to 720. I hope you have idea about the factorial. Let me give you some exceptional cases. 0 factorial, which is equal to 1, and 1 factorial, which is equal to 1. Okay, so how do we execute this? How do we write solution for this? How do we write solution for this? Okay, so let me show you what user will have to take value from the, sorry, user will have to enter one value. Let's say user will enter value in variable n. Let's say it is 5. Then we have to set some variable. We will take one variable fact, which will be initialized by 1. Then fact, which is initialized by 1. Okay, then what do we do? we will multiply fact is equal to fact into n. What is the value of n? 5. Okay, then we will decrement the value of n by 1, and we will check if n is greater than 0. If it is 0, then again we have to perform this step. Okay, like this we have to implement the logic. So let me explain again. Okay, first of all, what is the step? First of all, we have to take value from user, let's say n. Second step, we have to initialize two variable, fact, sorry, only one variable, fact, which is equal to 1. Then third, what is the third step? We have to check if n equal to 0 or n equal to 1. If n equal to 0, n equal to 1, then what is the factorial? It is 1. If it is not that, then we have to perform this step. Fact is equal to fact into n, then n is equal to n minus 1. Then check, we have to check if n is greater than 0, then go to step D here. If it is n is greater than 0, then result is in which variable? Fact variable, like this. Okay, so let's start writing the solution. As you can see, the input for this algorithm is a, number a. Okay, instead of number a you have to write number n. Output factorial of number n. Very first step is start. Step 2, user will have to enter number n. Step 3, as I told you, we have to set one variable fact which will be initialized by 1. Step 4, we have to check if n is equal to 0 or n is equal to 1, then definitely the factorial of that number is 1. If it is not equal to 0, if it is not equal to 1, then we have to calculate fact is equal to fact into n. Then we have to decrement n by 1. Then if n is greater than 0, then we have to repeat step from step 5. If this condition becomes false, then we have to print fact and 9. Okay, so let me explain this algorithm by taking one value. Let's say n equal to 5. This step exists, this also fact, which is initialized by 1. You can see n equal to 0, n equal to 1. No, this both condition becomes false, so we have to execute step number 5. You can see so what is the value of fact? What is the value of fact? 1. What is the value of n? 5. 1 into 5, 5. The value of fact will become 5. Then we have to decrement n by 1. N is equal to n minus 1. What is the value of n? 5. 5 minus 1, which is equal to 4. The value of n will become 4. You can see the value of n is still greater than 0. Then we have to execute same step number 5 again. You can see fact. What is the value of fact? 5. What is the value of n? 4. 5 into 4, 20. The value of fact will become 20 after executing this step. And you have to decrement the value of n by 1. N is equal to n minus 1. What is the value of n? It is 4. 4 minus 1, which is 3. Okay, still n is greater than 0. Then we have to again execute step number 5. You can see the step number 5, fact is equal to fact into n. What is the value of fact? 20. What is the value of n? 3, which is equal to 60. The value of fact will become 60 after executing this step. Then we have to execute step number 6. N is equal to n minus 1. What is the value of n right now? 3. 3 minus 1, which is equal to 2. Okay, the value of n will become 2. 2 is still greater than 0. Then we have to execute again step number 5. Fact is equal to fact into n. What is the value of fact? 60. What is the value of n? 2. 60 into 2, 120. The value of fact will become 120. N is equal to n minus 1. What is the value of 2 minus 1? What is the value of n? 2. 2 minus 1, which is equal to 1. Sorry, it would be definitely 120. It is 1. N is greater than 0. Yes, n is greater than 0. Again, we have to execute this step number 5. Fact is equal to fact into n. What is the value of fact? 120. What is the value of n? 1. 120. The value of fact still 120. N is equal to n minus 1. What is the value of 1? N. It is 1 minus 1, 0. Now the value of n is 0. You have to check this condition. N is greater than 0. 0 is greater than 0, which is false. Then you have to execute this step number 8. What is 8? Step number print fact. What is the value of fact? It is 120. Now you can see 5 factor, as I told you, 5 factorial is equal to 5 into 4 into 3 into 2 into 1, which is equal to 120. We are getting the same result here, right? If you have any doubt regarding this, regarding the solution of this, you can write in the comment box. I hope you got it. So our next problem is write an algorithm to print the Fibonacci series up to n term. So before we design the algorithm for this problem, you must have idea about the Fibonacci series. So let me show you what is Fibonacci series and how does it look like. Okay, you can see the Fibonacci series. The Fibonacci numbers are the numbers in the following integer sequence: 0, let me close this. Okay. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. Right, so you can see in mathematical terms the sequence fn of the Fibonacci series is defined by recurrence relation. You must have an idea about the recurrence relation, right? So I will show you, don't worry, how you can generate this series. Okay, let me give you an example. Okay, suppose you want to print Fibonacci series up to 5 terms. So very first term is always 0 and second term is always 1. This is fixed. How many terms we have printed so far? 2. So what is the third term? You have to add this 2. 0 plus 1, 1. What is the fourth term? 1 plus 1, 2. What is the fifth term? 1 plus 2, 3. Then find the sixth term. You have to add this 2 number, 2 plus 3, 5. Then find the seventh term. 5 plus 3, 8. What is the eighth term? 5 plus 8, 13, and so on. You can check on the Geeks for Geeks web page. You can see 0 plus 1, 1. 1 plus 2, 3. 2 plus 3, 5. 5 plus 3, 8. 8 plus 13, 21, and so on. I hope you have idea about this. Okay, so to design the solution for this given problem, we must have to take some variables, right? So let me show you how many variables we have to take. We will take one variable I, second variable j, then third term variable, fourth temp variable, and the variable n to store value from the user, that is number of terms. And I will initialize I by 0, j by 1, term by 2, temp by 0, and we will store value from the user into variable n. Okay, we have to take 5 variables. So let me write some steps. Okay, I will show you step by step in detail. But before we write the exact solution, let me show you some sketch for this sketch solution for this algorithm. Very first step, instead of a I should have to write first step, take value from user, right, and store in variable which n. Second, initialize I by 0, j by 1, term by 2, and temp by 0. Third, print I. Fourth, print j. Fifth, check if term is greater than n. If term is greater than n, then go to some step, right? Sixth step, if term is not greater than n, then calculate temp is equal to I plus j. 7, set I is equal to j. 8th step, set j is equal to temp. 9th step, calculate term is equal to term plus 1. Then go to which step? 4. Then go to which step? 4. Then 10. Stop. Right? So this would be our algorithm. We have to write go to step number 10. Okay. So this would be the algorithm. Let's say user wants to, let me take red pen. Okay. User wants to print how many terms? 5. Okay. Our algorithm will start from this. The value of n will be given by user, that is 5. I is equal to 0. J is equal to 1. Term is equal to 2. And temp is equal to 0. Print I. I am printing output here. Print I. What is the value of I? 0. Print J. What is the value of J? 1. Check term is greater than n. What is the value of term? You can see 2. What is the value of n? 5. 2 is greater than 5? No. Then calculate temp is equal to I plus j. What is the value of I? 0. What is the value of j? 1. Temp, the value of temp would be 0 plus 1, 1. Set I is equal to j. What is the value of I? 0. It will be initialized by, it will be assigned value of j, 1. J is equal to temp. What is the value of temp? 1. Now value of I is 1, j is 1. Term is equal to term plus 1. What is the value of term? 2. It will be incremented by 1. Term plus 1, that is 2 plus 1, 3. It would be 3. Then go to step number 4. What is the step number 4? Print j. What is the value of j? 1. Now you can see 0 plus 1, 1. Now again, value, what is the value of term? 3. 3 is greater than 5? No. Then again we have to calculate temp is equal to I plus j. What is the value of I? 1. What is the value of j? 1. 1 plus 1, 2. The value of temp would be 2. Set I is equal to j. It would be 1. Set j is equal to temp. It would be 2. I hope you are getting this. Then calculate term is equal to term plus 1. What is the value of term? 3. It will be increment by 1. It would be 4. Then go to again step number 4. Print j. What is the value of j? It is 2. You can see 1 plus 1, 2. Then what is the value of term? 4. 4 is greater than 5? No. Then again you have to you have to calculate this. Temp is equal to I plus j. What is the value of I? 1. What is the value of j? 2. 1 plus 2, 3. The value of temp would be 3. Then set I is equal to j. I will be assigned the value of j 2. What is the value? Set j is equal to temp. Step number 8. 3. Term is equal to term plus 1. 5. Okay, then go to step number 4. What is the step number 4? Print j. What is the value of j? 3. Now you can see what is the value of term? 5. What is the value of n? 5. 5 is greater than 5? No. Then stop here. You can see the 5 term 0, 1, 1, 2, 3. I hope you are getting this. Okay, let me remove this. Okay. As you can see, number of terms n, print the Fibonacci series up to term n would be the output. Step 1 always start. Step 2 we have to take user value from the user. Step 3 we have to initialize some variables I, j, term and temp as I explained. Step 4 we have to print I. Step 5 we have to print j. Step 6 we have to check whether the value of term is greater than n or not. If it is greater than n, then we have to stop here. If it is not greater than n, then we have to calculate temp is equal to I plus j. Set I plus j would be step 8. Set j is equal to temp would be step number 9. Step 10 we have to calculate term is equal to term plus 1, then we have to execute step number 5, and step 11 would be stop. I have already traced this algorithm. Okay, so if you have any doubts regarding these algorithms of repetition or looping structure, then you can write in the comment box below. So thank you. If you have not subscribed, or if you have not subscribed this channel, please do subscribe. And if you have any suggestions for this channel, then you can write in the chat box below. Thank you.